Okay, very good. Hey, I'm really glad to be with you today. You guys are one of the premier tugs, at least in this country. And now that Bulgaria's added in, it's probably the entire world. I'm really honored to be speaking with you today. We're going to talk a little bit about data sets that have all the data that you need in the data set, but they're just not structured properly, or they're not structured the way that you can get an answer. So we're going to take a look at some real world data sets. But first, just a little bit about me. I do live in Nashville. I'm a consultant. I still do some consulting. I'm also a grandfather, and I'm kind of semi-retired. I think it's important for you to know that I am not a data scientist, and I am not an IT professional, as we just witnessed when I tried to share my screen. But I have an engineering degree, and I also have a degree in business. And I spent most of my life working as a product manager or a business unit manager for consumer product companies. When I started using Tableau 5 years ago, I was an absolute zero. I didn't have a clue. And now, after 5 years, uh, I was just named for the fifth time as the Tableau Forum Ambassador, and I do happen to be a Zen Master also. Now, what I want to talk about today are real world data sets. And the first time I did this presentation, I don't know if he's in the room. Is Doc Elder in the room? If he is, just raise your hand and wave at everybody. I made this presentation for his undergraduate class. And we were talking about his class and what they were, the type of students they were. And we wanted to introduce them to some real world cases that you run into. Now, when I learned Tableau or any other language, we always started with what I call a solid data set. You can think of that Excel spreadsheet where every cell is full and the data is just absolutely solid, pretty easy to work with. But in the real world, we have data sets that don't quite look like that. The data sets have gaps in them, they have voids in them, and sometimes they're just plain sparse. And that's not because the data is dirty or the data source is a bad data source. It's just the way the data is collected. ERP systems like Oracle and SAP only record data when a transaction takes place. So if you don't make a sale today, there's no record for today in the data set. And then you have some third-party software that collects data for a specific purpose, but that may not be adequate to meet your needs. Well, what we're going to look at today are three real questions that came in to the forum, and these happen to be questions that I happen to answer. But we're going to look at three different types of questions. The first one is what's known as the two-date problem. It's a classic. It's when you have a data set where each record has a start date and an end date, and you want to look across the data set and understand what happened in between. The second is what happens when you have a data set that is very solid at higher levels of aggregation. At the top of that pyramid, the data set is very solid. But as you drill down into it, you hit voids and the data becomes sparse. And then the third example we're going to talk about is maybe something you ran into yourself, is when you hit a void in the data set and all of a sudden the screen goes blank. Let's take a look at that first example. It's the two-date problem. This is classic. We see this maybe 2 or 3 times a week in one form or another. It's where each record has a start date and an end date, or a way to calculate the end date, but you want to know what's happening across all the dates. And this is the type of thing that you might be a finance manager or a loan manager in a bank. And you're looking across a number of different loans that are outstanding. They all have different start dates. You know what the monthly payment is, and you're trying to determine your cash flow. Or you could be like the HR manager who sent us this data set. And his question was, he says, look, I've got a number of job recs that were open throughout the year. And what I'd like to do is I'd like to see how many I filled each month and how many were still open. And he looked at it, I looked at his data set, and he had a start date and he had an end date, and then he had some other information. And I've cleaned this up a little bit. And what he was really saying is, I can't get these things to line up. I've tried this, but it just doesn't line up, and it just doesn't make any sense. What am I doing wrong? Well, if we think about what he's dealing with, he's got 2 dates, and they're totally independent dates. They don't really know each other. What he wanted and what he needed was a calendar, and he didn't have a calendar. He wants to put his dates on a calendar and see what's happening across those months. Well, this is a fairly simple data set. So what I looked at was just going to Excel, and I made a scaffold. And just very simply, I put the first date of each month, January through December, and that date is that's going to form our calendar, if you will, when we join it to his other data set. Now, what we want to do is we want each record in this data set to join with every record in our scaffold. And to do that, we use what's known as a Cartesian join. And it's very easy to do. We just bring the two data sets together, and we can create a relationship calculation, just 1 = 1. And that's all that's needed to create the scaffold. And now when we go back to our data and we bring the scaffold dates to columns and add as open job recs, it's beginning to look like what we need. Now, his first question was, how many jobs did I fill each month? So at this point, we just added a simple calculation. And I like to use LODs. Someone's probably sitting there saying, well, you really don't have to use an LOD for this. And you're right. In his real data, we did have to use an LOD, but I just like to use LODs, and I used an LOD for this, and we'll see why later. Okay. All we did here was take a look to see if the first date and date trunk is going to return the first date of the month. If we take a look at the first date of the month for when the job was filled, and if it's the same as the first date of the month for the date scaffold, I bring back the job ID, and then we just count those. And you can see when we do that, we can look across there and we can see, well, yeah, this job was filled in October, so we got a value of 1 out there. And all we're going to do at that point is we just add them together. Now, his second question was, well, how many jobs were still open? We're going to use the same approach. It's the same idea again, except we have to check to see that the scaffold date was after the job was open, but before the job was closed. And when we do that and bring it to the viz, we can see here that, yeah, sure enough, this date was it was open in September, was filled in October. This date was open and it's never been filled. So we're counting the jobs that were still open by month, and we can total those. Well, once you've got that, now it's very easy to look at that in any different way. You can look at it as a text chart, or you can look at it as any type of chart that you want. Well, we take a step back. His issue, what he was facing, is he had a data set that he got from some third-party software that he was using, and had all the information he needed, but it didn't have a calendar. So we had to sit back and say, well, how can we make a calendar? And we made a calendar by creating a scaffold in Excel and joining it together with a Cartesian join. That's all there was to it. And once we did that, the rest of the analysis was very simple to do. Now, our second example takes a look at what happens when you have a data set that's very dense at high levels of aggregation, and it falls apart and breaks down when you start drilling into the data. And for that, we're going to use an inventory model. The member that wrote the question was a inventory analyst, and he was having trouble calculating a metric that they use known as days on hand. And those of you who are familiar with inventory, know what that is, and we'll get into it a bit later here. But we're going to look at the inventory model, and I think I need to explain a little bit about where his data came from and why he was having problems. He was pulling data out of an ERP system. It was either Oracle or SAP. And if you know anything about those systems, they create a record anytime a transaction takes place. And they create that record at the lowest level, and we're going to be taking a look at sales data. So this was coming off of a sales order. And then internally inside the ERP system, there's a hierarchy. And that hierarchy will total from the line level up to the product sales, up to the product line sales in total. And if we were to look at that, at the lowest level, the data coming off that sales invoice is precise. We know who bought the product, when they bought it, what they bought. Think of it like line level data, the quantity that they bought, and the dollars that they bought. Okay. And as that data gets aggregated, that data is still very accurate. I mean, all we're doing is adding numbers together. You know, and computers do a pretty good job of that. We're adding numbers together, so the data is still very, very accurate till we get to the top level, where we have two numbers. We have the total quantity and we have the total dollars. It's accurate, but it's a whole lot less useful. Okay. Now, the next step in his process is to take that same data and create a forecast. And sometimes it's called a demand forecast or a sales forecast, but that's the forecast that feeds his MRP system, determines his, they set the production schedule and production orders, and you start buying materials. Now, that forecasting process starts at the top, taking what they know, this very accurate but not very useful total sales data, and starts breaking it down by product, by SKU, and eventually by some date that's in there. So we're starting with this most accurate number, which is, you know, just a dollar value and a quantity value, and you disaggregate by product and by color and by SKU. And then we start looking at his data was actually wanted to get down to days, but you looked like days or weeks, and you had a time element in here. And that's the forecast that's being passed on to do the production planning. Now, everybody involved in this process, whether it's the inventory manager, the product manager, or somebody in manufacturing, they understand that this disaggregation process adds a lot of question in just how accurate the number is. There's a lot of assumptions being made along the way. So while this bottom line number is the number that's most useful, that's absolutely essential to do the production planning, it's also the least accurate number on the page. And for all those reasons, inventory managers and product managers like to have a little barometer, a little very easy to calculate metric to tell them, well, are things on plan? Are they going off plan? Or is there something I need to look at? And that measure and that metric is usually referred to as days or days on hand or days inventory. A lot of different names, same calculation. All you do is you take the inventory level in units and divide it by the average daily sales. And you end up with days. Well, that's pretty easy to figure out. And our users send in data that look like this. And he said, I've got this data and it works. I know it works real well. And he says, I'm calculating values here that are pretty good. But something's going wrong when I drill down into this data. It doesn't seem to be doing what I think it should be doing. And to look at the calculation, all he's doing is taking this number, his inventory number that comes out of his ERP system, and he's dividing it by the average of the sales numbers that come out of his ERP system and to calculate the days on hand. So if we take a look at his actual calculations here, so look at his days on hand calculation. This column right over here is nothing more than the inventory divided by the 7 days of sales. And if we take a look at his 7 days of sales number, now when we look at this, for those of you who are familiar with table calculations, right away you're beginning to see, well, maybe this is where the problem is. He's using a function called window average, a table calculation, to sum the last 7 records that are recorded in the database. And at very high levels, very aggregated levels in his data, there's a sale made every day. But as you start disaggregating the sale, there aren't sales made every day. So I'm going to open up he had a filter here because he only wanted to look at the last day. I'm going to open this filter up and we're going to take a look. And let's take a look at company B. And we can take a look at the last 7 records here. And they started on the 10th and ended on the 27th. Those were 17 days worth of sales. So while he thought he was calculating his days on hand accurately, he really wasn't calculating the days on hand accurately. And if we open this up, and I think I can open this up without too much trouble, and just take a look at the missing data, you can see what the last 7 days of sales actually look like. There was a lot of voids in the data set. As a matter of fact, this is a sparse data set. There's more missing data, at least for company B, than there's actual data on hand. So now we're left with, how are we going to correct this problem? We need to fill in a record for each one of these missing days for each one of these customers. And to do that, this time I created the scaffold. It's getting a little bit too involved to do in Excel. although you could. I went out and I used prep to create the scaffold and join the two data sets together. And we did nothing more here than take his individual dates and his customer names, and once again used a Cartesian join, 1 = 1, to join these two data sets together and expand the data set. And then we came back and joined that to his inventory data. So now we filled out the data set. Now I want to get back to where we were after the data was scaffolded. I added a ZN function so that we had a 0 for all the sales that were missing. And you can see now we've actually got 7 days worth of sales that don't end on the 27th, but end on the 29th, which are actually the last date in his data set. And it covers this period of time. And I'm just going to take false off here so we can look at where he originally started. He wasn't looking at 11 days worth of sales. He was just looking at 66 days worth of sales for his days on hand. So let's take a step back again. I mean, here's and this guy was a very good, I'm going to call him a subject matter expert or a SME. He was a very good inventory planner and very good inventory analyst. The issue that he had was his data was sparse. And he didn't really understand how that data coming from his ERP system could be inaccurate. You know, it was something that just didn't connect real well with him. But that's okay. That's not his responsibility to understand that. It's our responsibility as developers or designers or whatever term you use as an analyst to understand how the data structure can affect the overall results that you get in the data set. And it's our responsibility to deal with it and make it right for him. Now, I'm going to go on to the last topic, and that's what happens when we have voids in the data. Okay, we just looked at an example where the data was sparse, where there's a lot of data missing. This is a little different situation. This is a situation where you're filtering the data, and all of a sudden the screen goes blank, and you hit what I call a no record null. There's no record in the data set for the combination that you hit. Okay, and that's very different than a empty cell null, where there is a record, but there's just no value in that record. And the easiest way to look at this, or to visualize what's going on, is with some superstore data. That's the same data set that you got when you got your copy of Tableau. And as a matter of fact, the person that wrote in the question showed us the example in using the same data set, using the superstore data set. And the situation arises when you have data and you filter down to the point there's no data available to plot. And all I've done here is I've taken a look at a couple of data, a couple of subcategories, arts and envelopes, and I looked at a couple of different year months, September and February, and we're just looking at, you know, the sales on a daily basis. And if I come in here and I take out September, we still got data, something's still showing up, but if I take out art, all of a sudden my screen goes blank. And it goes blank because there's no data. There's no data associated with February 16th for envelopes. There's nothing to bring back. Now, you may have experienced this, and you may say, oh, well, I'll just change my filter around, or you may not really know what was going on. But our user here used the same data set to illustrate her problem. Now, first of all, she's much more experienced in Tableau than I am. She's been using it a whole lot longer than I've been using Tableau. And on top of that, she's a very good analyst. And she sent this problem in, and she said, well, look, I'm doing this analysis, and the analysis she was doing is sort of an advanced analysis. She was using small multiples to show what's happening across all the values in an entire dimension as you make changes to filters or values that will affect that data. And obviously, superstore data is not her real data. If you haven't done this type of analysis, you got to look into it. Kevin Flurledge on his site has a great plug and play model that you can use to do this type of analysis. But her question came to us, the same type of question. She said, look, I've got 17 subcategories, And that's how many are in the superstore data set. And I can see them all and everything's fine. But when I come back in and I filter out some data, all of a sudden, I've only got 13. And she said, well, she had two questions. The first question was, what happened? And then she said, I can't possibly explain this to my user. They just wouldn't understand what's going on. What happened and how do I deal with it? Well, what happened, and what happened, and as you know by now, what happened is she's hit a void in the data set. And the solution again is to come back and use a scaffold to flush out that data set so that every record exists in the data set, and then we'll be able to look at it and plot it out. Same process again. I went out and used Prep. Prep's a good tool for this. It's a great tool for it. There are others that are available, but Prep's a great tool. And all I did was take a look at every date and every subcategory, join the two together, once again, using this 1 = 1 Cartesian join criteria. And you can see down here how it just exploded the data set. There's now like 25,000 records in the data set. Then we came back in and joined back in her original data. And then we were able to look back at the data set, bring that back into Tableau. And now when we look at the data, and I've added a ZN function to put a 0 where there are no sales, where the cell is null. We've got a cell now, a real cell, and we're going to put a 0 in it instead of having an empty cell now. And now when we look at the data, there's 17 categories. And when we filter out September and we're left only with February, there's still 17 categories. 4 of them, bookcases, envelopes, copiers, and machines, don't have any sales. There are no values in the data set, but we didn't lose the data set, and she was still able to explain it to her users. If you take a look at the actual data that underlies this, and you can look in here and you can see here where I put in the ZN, there are no sales, there are no values for sales, and there are no values for profit. But by scaffolding the data, we were able to force a cell in each one of those combinations, filling the voids with the ZN function. Okay. Well, those are the 3 examples I wanted to share with you today. There could be many more use case examples. These 3 examples, you happen to be able to work with, you happen to be able to correct the problem with the scaffold. Obviously, that's why I chose them. There are other examples where you have to restructure data sets, where you have to use a different technique to get the structure that you need to meet your overall need and to get an answer. A couple of important things to understand here is your end user is going to be a great deal of help in the situation, but he's not going to understand the problem. You have to think through it and solve it for him.